Okay. Well, good evening, graduate UNSY 501 and 502 students. First, as a reminder, we are recording this session. A copy is going to be made available for those who are unable to attend tonight. Next, for the format of our meeting, I'm going to start by introducing our guest, and then we're going to proceed into a Q&A facilitated discussion. Afterwards, I'm going to open up the session to a larger class-wide Q&A. In the meantime, I do ask that you all mute your mics, save any questions to the end, and that you use the hand raise icon to indicate when you do have a question. I'll call on each of you in order when possible. And with that, I am just really excited to welcome you to the 40th session of the UNSY Guest SME Speaker Series. This is the first of 3 for the term. I'm Dr. Brent Twilliger, the program coordinator for the Master of Science in Uncrewed and Autonomous Systems degree here at Embry-Riddle Worldwide. Tonight, we are joined by our guest subject matter expert, PSchubert. Peter's the co-founder and director of engineering at Posiedon Robotics, which specializes in the design and development of remotely operated underwater vehicles, or ROVs. With a deep-rooted passion for electronics and robotics dating back to the early 1990s, he began his career at Schilling Robotics in 2005, progressing from technician to field service engineer, gaining hands-on experience with subsea technology. In 2010, he transitioned to piloting ROVs, working on offshore projects across the North Sea, Australia, Africa, and the Pacific, supporting industries such as oil and gas, deep sea exploration, and documentary filmmaking, including a History Channel project identifying a World War II wreck. Drawing from his extensive field experience, Peter and his wife Christine founded Posiedon Robotics in 2018 to innovate and enhance small ROV technology, ensuring designs are tailored to real-world operating needs rather than forcing tasks to fit the vehicle. And that's something I really want my 501 students to take note of. That really embodies the principle that we try to impress upon students that are new to this field, that as exciting as the technology and the vehicles might be, it's at the end of the day, it's figuring out what is it you're trying to accomplish and finding the right tools that match that use case or application or need. And with that, I'd like to give just a really warm welcome to Peter. I'm excited to explore this space together.
All right, thank you, Doctor, for having me on here. I do a lot of public speaking, but it's generally little 1 or 2 minute chunks that are for high schools, things like that, product introductions at trade shows and things. So please bear with me here, and I'd certainly love some pointers from you and the rest of the class when we're done. As he mentioned, I've been doing this for probably a lot longer than I should have, but I just fell in love with robotics from a very early age. When other kids in school were, drawing cowboys and Indians or what have you, I was generally trying to sketch spacecraft. I was fascinated by the Viking Mars landers and the Apollo missions, things like that. Born in 1980, so of course I didn't get to see most of that interesting stuff live. But space, aerospace, and then when I was just a kid, I remember the discovery of Titanic all over the news. And so that's kind of what really got me excited in subsea. I then got into drones, as we call them now, but I was into model aircraft from a very early age. I struggled in school, but my parents kind of let me run wild with robotics. And so eventually that kind of forced me to catch up when I realized at about 16, and I'd been slacking off, that I really wanted to do engineering, and I was struggling in Algebra 1, and I was going to have to get to Calc 3 pretty quickly. So, technology can be used, I think, as a motivation and not just a tool. So going from that, I remember working with a couple of professors from Sacramento State back in the day, one of which was teaching up at a junior college when I was in high school. But Mike Dobeck was his name, and he had managed to get himself involved with JPL. And so one of my first courses in college, even though I was just taking my intro English and everything else. One of my first courses at a junior college was actually a radio direction finder for the Mars sample return mission. It was a European Space Agency project. It never happened. It's sitting in a warehouse somewhere. But the point is, these bits of technology, it always seems like these things are a long ways away. Like, you know, it's fun to do computer programming or mechanical engineering or aeronautical engineering, but you often think, I'll never get a chance to work on anything interesting. And then you're building a circuit board destined for Mars, or kind of left it there. I just started focusing on what I wanted to do and how I could actually get through college, because I was not a very good student, had some learning disabilities, but really found my passion in there, and math and physics. And at some point, one of my old classmates, turned out he was working for Schilling Robotics, and they desperately needed some people. I hadn't ever considered I would get into subsea. And 24 hours later, I was working as a technician, repairing and rebuilding some of these old ROVs. So just to differentiate, you have remotely operated vehicles, you have autonomous underwater vehicles, you have uncrewed surface vehicles or unmanned surface vehicles, you have fully autonomous surface vehicles or remotely controlled ones. The way we separate an ROV from an AUV is really just there's a tether. So, number of reasons for it. Battery power not being very optimal is one, but then something that I can go into later is it takes a lot of power to push something through the water. One of our interns here, he's since gone on to work on his aeronautical engineering degree, and he's working on projects. He's doing fluid modeling at 1,200 knots speeds like this, supersonic speeds. We are really lucky to push 3 knots. There are ROVs that will do 6 and 7, but no one uses them because almost any environment in the world, you basically think you're flying over the surface at warp speed. You can't see anything because your visibility may only be a meter or two. So 5 knots, you can almost water ski behind it. So things happen slower. There's a tremendous amount of drag. Water is over 700 times denser than air. And so we just need some serious horsepower to move things through it. But very interesting world. And then as he said, I ended up working at a company that made these. I had really almost no knowledge of it other than they used them to find, Titanic and number of lost US and Russian submarines. And suddenly I found myself working on these things that were coming back from the University of Bremen, Germany. They were coming back from Woods Hole and places like that, and get to put these together. Sometimes the scientists would come through. Dr. Ballard himself came through once. It was interesting to meet him. And then, but you're just wrenching on things. And then the market slowed down pretty bad in 2010. And I figured I may as well look offshore. And I found something. And I ended up working as an ROV pilot, only on the larger ones. They're about the size of an SUV. So they'll be 10, 12 feet long, 6, 7 feet high, 6, 7 feet wide, and maybe about 10,000 pounds. So quite large. They're usually 4,000 meter or 1.5 to 2.5 mile depth rating, depending on where they're working. And they're quite expensive. Whereas, so in some ways you could compare it to aeronautical engineering or perhaps space flight, where you're not making thousands of something, you're making one of something, you're iterating it, you're making 2. Customer has another request, and then you make 5 in a slightly different flavor, and then that product line might be dead. A lot of vehicles might be 50 or 100 of the same, relatively the same flavor, but there'll be a dozen revisions in there. And so you just don't. It's not like making a Robinson helicopter where you'll make thousands of the same thing or tens of thousands. But it's also not two different bits of thought here. One is it's We don't have the kind of budgets that you do in, for instance, space flight. It's not going to the moon. We can get another shot pretty easily. And so people don't put this, comparing it to a Mars lander, you got to spend 3 or 4 years building it, 2 years to get it there, and your entry, descent, landing sequence has to go right in about 3 minutes, or your entire trip's wasted. With this, and the other half of the equation being that there's nobody inside there. So unlike any of these actual submersibles, like the tragedy at Titanic recently, there's no one in there. If something implodes, it's expensive, but it's nothing more than dollars and cents and a bunch of spare parts. So we have the liberty. We're not constrained like somebody at Boeing. We have the liberty to try some fairly radical designs. If we want to try making something out of ceramic or carbon fiber, we're able to do it. We're able to risk it. We'll try to minimize that, but it's really only from a financial standpoint. So we get to do some interesting engineering, and it can be a fun place. I've got a friend working at Boeing, and over there, even if you have a master's in aerospace engineering, you don't get to really do anything. It'll be an exciting career, but you will get to work on one very narrow discipline, and you'll have a lot of people looking over your shoulder, checking your work for the first 10 or 15 years. Here, several companies I've worked at, I have been half or all of the engineering department. So
Can I ask your perspective as somebody who's worked as both an ROV pilot as well as an engineer? How has your personal perspective on subsea technology evolved over the last 15 years? What major things have happened, or what do you see has changed the usage of this technology?
that's a really good question. Thank you for asking that. The biggest thing that's changed is that things are not changing very fast. Something something I've really noticed, the industry was late 1980s technology when I went into it, and it's now mid 1990s technology. You'd be amazed the number of third-party devices. Something's not working, the customer gives you permission to open up the can, and there's this huge titanium bottle. You take the lid off, and there's a pentium 2 hot glued into the side, and then they've got an RS-485 converter bottle, and you're sending, or a converter, and you're sending 9600 bits 9600 bits per second over a twisted pair, and you're trying to power the thing on 24 volts, only to step it down to 5 volts DC. They'll they'll have a lot of, really, what I started learning as a hobbyist in the early 90s. A lot of those things will still be in there. You'll find the uh, the old fashioned LM 7805 3 terminal voltage regulator in there, just hand soldered in place, and some dead bug parts in there. There, that's slowly starting to change. There's a couple things that go with it. One is, well, the design and use of ROVs. I wouldn't say it's not that it's not regulated, but it doesn't have the kind of oversight that the FAA gives you in aircraft. What happens though? They're used on projects, combination of defense, undersea cables and telecoms, renewables, but more than half of it is oil and gas. And oil and gas is very heavily regulated. It's very heavily documented. And especially in the cases of like supporting oil platforms or oil and gas pipelines, it's very heavily scrutinized. So if you have, something like the Deepwater Horizon disaster, sad as it was, they had a lot of paperwork in place already. They missed a couple of things. People made some serious errors there. And then they quadrupled the paperwork. And so one of the drivers of technology, and one of the limiters by the same token, is that people say we must do an inspection with a black and white camera, for instance, because we get better contrast. That was true when you had an NTSC camera with 480 TV lines and it was completely analog, and you had terrible light sensitivity. your modern iPhone or camera. I mean, even my cheap $200 Motorola camera here is 10 times better than any black and white camera you could get back in the day. This actually it was an artifact of photo multiplier tubes in the 1980s. So they were literally comparing, and so you still get people who say, I would like a an old analog television camera with a Gen 2 1975 night vision binocular on the front of that in a bottle that cost about $40,000 to machine. I would prefer that over your tiny little CMOS color HD camera with 10 times the light sensitivity. So we have to push through that a little bit, and you can only go so far with it. Same thing in avionics. I'm sure you've seen you can't just put a Raspberry Pi into a Cessna and start running commercial flights with it, even though it might well be better. You have to prove it first. We don't have as much difficulty proving it, but you have to get somebody somewhere at Shell or BP or then the various US and European agencies to actually sit down and say, okay, it's ridiculous to have an analog camera when we could have it in 4K and do SLAM modeling of it and get an infinitely superior product, but we are going to have to grant you an exception for that. As we get these, it's turning out a lot better. But so we have that limitation and things are changing very slowly. Plus, I would say a lot of the equipment, it lasts decades. So it was fairly well made to begin with. There's a lot of foresight put into the material selection and things. And so you get something like this camera. This is a prototype I made years ago. It's been to the bottom of the Mediterranean. And that stainless steel housing will be around in 25 years if I need it. I've dove it a few times, but and that's just a prototype. A lot of this production equipment in titanium, the electronics inside are good for 30 years. So people just don't have a need to change it. Where it is changing, and I'll get through this part quickly. Where it is changing is that people have suddenly gotten a lot of these tools. SLAM cameras and photogrammetry, for instance, has suddenly started to replace older sonars. So we have, for instance, the old sonars would be a very large rotating head where you have a single transducer. It sends out a ping. You receive that, and then it will rotate on the stepper motor 2 degrees or something like that. Send out a ping, you wait for it. A modern sonar, these are made possible because of something called a field programmable gate array, or an FPGA. They're used in phased arrays in radars, for instance. Missile detection and countermeasure systems will use these because you have incredibly precise timing. And so this one actually does proper beam forming, where there's a single, it's actually a linear array in here, but it'll send out a nice, fairly equal pulse, fairly carefully timed. But then we do beam forming on a set of receiver elements in here, and you can get 512 beams. So this actually looks almost exactly like a medical ultrasound. If you ever seen an ultrasound of your kid or your nephew or your brother or something when their mom's pregnant, looks almost like that. You can make out the details, you can see things move in real time, and it's just incredibly superior. And then we go to another technology called SLAM, where you can use 2 cameras and, I'm paraphrasing, but line recognition, object detection, and it's able to build and scale a model as well, and build a point cloud, as well as wrapping textures around it from actual photos. We just assisted somebody with a pipeline inspection at a hydroelectric facility. We're able to map an old valve to within about 0.5 millimeter of precision, and we're able to do this whole thing in just a couple of minutes, just flying the ROV around it, just looking at it. And I think as people are getting that, the old-fashioned method was to send a diver or a vehicle in there with a measuring stick and try to hold it up against it and say, that's about 14 centimeters, maybe it's 20. And now we can map it to 0.5 millimeter. So as people are getting this is helping. But I think it's a really exciting time now because we've had a lot of limitation in a few things. We didn't have enough computing power to really put good smarts inside of one of these. People have AUVs, autonomous underwater vehicles, but they're largely defense. Mostly they're used to, they put them in the middle of the South Pacific somewhere to look for a lost, fighter jet from a foreign country or something, or to recover some space debris or F-18 or something that you lost in the middle of the Pacific in 10,000 feet of water. And so they're pre-programmed. They do a simple mowing the lawn pattern, and they'll sit out there for a week. Most of them don't even use batteries. They have enormous hydrogen fuel cells, but if you have to ask how much it costs, you can't afford one. They're really only in the realm of large defense agencies and militaries. But now, with a couple of the new, for instance, the NVIDIA Jetson Xavier and Nano cards, there's enough processing power in that to do pretty decent object detection and recognition from the camera and from the sonar now. So I think there's going to be a tremendous amount of autonomy in the next few years for people that have the budgets to do it. We're going to take a stab at it pretty quickly here, but it's going to be really exciting because once you get rid of the boat, the beauty of a small aerial drone is you can basically go out your back door and fly it. You don't need much. You can transport it to the site easily. If you want to go 100 miles offshore, you need a 50-foot boat, a 100-foot boat. You need 12 people on board it. You need enough fuel. Basically, even for a low budget science university project, as cheap as you can get it, somebody's going to charge you 10 grand a day to do that, just to get the equipment on site and back. So you can't have these low cost projects. But if you can take a very small vehicle out, and in particular with deep water, because you may need, 10, 20,000 feet of steel armored umbilicals, what we're normally using now. So you've got 10 tons over the side. Well, you need a 300 or 400 foot vessel with an enormous beam. You got to have a lot of equipment in there. You're now talking $40,000-$50,000 a day minimum. Again, even if you're not making any profit on it. But if you can go out there with a small vessel, you can take an ROV the size of the one behind me and literally truck it over the side. You're close to some interesting sea life. You have a SMS deposit. If you want to go see some tube worms on a seafloor smoker, you can take a sailboat out there with 3 people on it, get the right coordinates, throw this thing over the side, set your watch, give it 5 hours. It'll be back with some tube worms.
Wow.
And so that's something we could start to do at very, very low cost now. So I think it opens up to all these people that are in, and we've sold some to Stanford University. And for me, I know a lot of people either at Stanford or over at the Western Flyer Foundation that we're sponsors of. And there's for everyone interested in marine biology that's working on their master's or their PhD that has an interesting idea and gets funding, there's 100 of them that have a really cool project, but they just need somebody to write them $1 million check to go and do the research. And we really want to be able to open that up more, not just for the science community, but plenty of things we use divers for, plenty of telecoms work that if you can get rid of the big boat, if you can take a tiny little rib boat out there and just throw something over the side or throw it over the side with a small fiber optic cable and its own batteries, if you can eliminate the top side equipment, all the personnel and all the heavy equipment that's needed to operate this, and just get to a small boat deploying it, or even a totally autonomous or just a little radio controlled uncrewed vessel taking it out there, you can get the cost down to nothing now. So you may well be able to get a lot of people working on corals or what have you, or wreck hunting. A lot of people with like Project Recover. They're just limited by boats. They need boats, they need tanks for the divers, etc. And that costs money. If you can get them a cheaper ROV and the ability to get to deep water, they could do an awful lot more with an awful lot less. So I think that that's the way the industry is going. More people cutting the tether. Plus, we have we had Iridium for decades, but now with things like Starlink, people are actually operating these ROVs from not just remotely from the boat; they're operating them remotely from the beach, and that's really opened up a lot of other possibilities. You can leave something tethered to a buoy in the middle of the Pacific at 25,000 feet of water and just leave it there, and you can check in on it and see if any squid have swam by in the last week. So does that answer your
You
question?
mentioned Oh yeah, yeah, definitely. I'd like to kind of pick up on some more of what you were talking about as far as challenges and emerging trends. Uh, you mentioned how you see autonomy growing in this field and how you're starting to see the availability of some resources and technology associated with AI. What are some different ways that you see AI potentially influencing the next generation of ROVs and subsea operations?
Excuse me. Well, I would say the biggest one is just getting the driver actually into the vehicle. As you know, with manned submersibles, with occupied submersibles, any of these tourist boats, or even a full blown, submarine NR1 or whatever it would be, a person is relatively large compared to a computer, and a person has a lot of requirements. You need oxygen, you need CO2 scrubbers, you need to keep warm, and it's about 3 degrees Celsius down there. It's not very comfortable. As a lot of these submariners would point out, at adding a bathroom and a tiny little submersible is not really an option sometimes. So yeah, it's an extremely limited environment. Being able to get rid of the boat on up top, being able to put it in there, I I think I think where it's going short term over just the next year here, somebody we've been working with, Beam out of the UK, they've got a lot of projects going. They're trying to do autonomous ROVs, so not AUVs, but an actual remotely operated vehicle, but using an acoustic link. But then the vehicle has its own smarts. You cut the tether. They're trying to do a lot of wind farm tie-ins, the cable inspections, the anode maintenance, and things like that. Um, they and a lot of others are looking at doing this both fully autonomous, but also in like this hybrid mode where Oceaneering is a company that pioneered this with their Freedom vehicle, where it's an ROV, but it's also an AUV. It's an ROV that's powered through a tether, but it can disconnect its own tether and just fly off a few miles to another location, plug into a tether that's at, say, another well tree in an oil field, or you have the U.S. military has been looking at it for security because there's a lot of assets subsea that are very, very vulnerable. There's no way for people to guard them. And so having something that can go from area to area doing inspections, but can recharge itself is very important down there. So short term, I think having enough smarts that you can do some basic navigation, object detection, object avoidance, but that you could do it kind of how some people have been plugging in Jetson Nanos and Raspberry Pis into small drones, putting a camera on them and doing object detection just visually with some deep learning there. And also a big one is that's already being used is object detection and recognition. It's very important because most of what we do subsea, you'll do some manipulation, but the vast majority people are just doing surveys and they're just saying, fly down there, tell me if you see a gas seep. No gas seep, okay, fly back. There's no reason for a person to do that. Artificial intelligence, even small, locally based deep learning algorithms are good enough to do that now. You can do that with a Jetson Nano board now. And so that's short term. Longer term, I think a lot of these vehicles are going to completely cut the cord. They're always going to take some kind of maintenance, but I think what they're going to be used for is basically smart decision making in the way that I think a lot of militaries are looking at drones now, which is you just fire and forget. It goes out, it patrols, it's able to do its own mission planning, it's able to use deadly force if it needs, it's able to return. I think we can get over the next few years to a case where these AUVs are going out, they're patrolling areas, for instance, they're monitoring a port or something, listening for divers, and they're able to go and identify them and flag them and alert people. Or the there's a couple people involved in this up in Canada, and we're trying to work with them a bit. But one thing that's I've always wanted to do, cold water drownings, some people believe you may have up to about 2 hours to actually revive somebody effectively, depending on the conditions. Put them straight into a hyperbaric chamber with very high oxygen content, for instance. But 1 to 2 hours may be the realm where you could actually save someone who fell through the ice on a cold lake. We actually just had somebody in northern Arizona here walking across the lake here, broke through, and it's 4 or 5 hours before the dive team gets on site. But these could be made small enough and cheap enough for something like that. I think there's enough smarts now, just the computers they have. The problem is getting all the personnel on site and getting someone who knows how to fly the equipment and getting the equipment, putting everything out there, making sure it's safe first. If you had a vehicle the size of the one behind me that you could keep in a sheriff's patrol car in an area that has a lot of lakes, in Minnesota or something, if you could just press a button, light turns green, you throw it in the hole with a string attached to it, and it flies around and tries to identify a body. If it's still water like a lake, usually they haven't gone very far. They are usually negatively buoyant, sink pretty quickly. If you can make one that's completely autonomous and it just hunts for the victim, quickly grabs them, and then starts flying back up, flashing a beacon, you just pull them back up on a string, you could maybe get to a spot where they could save. It'd be a small percentage, but you could actually recover and revive and save the life of a small percentage of these actual victims that fall through the ice. So I think that's going to be much more practical. I think that's going to start being an actual product in the next couple of years here. So it's a good use of AI.
With offshore wind, deep sea mineral exploration, and even scientific missions growing in visibility and opportunity, which use cases or applications, especially, considering the availability of lower cost designs, that are portable and reliable, like you mentioned and demonstrated, what use cases do you see expanding the most in the next, say, 5 to 10 years?
Honestly, I think security more than anything else. Talking with some people at talking with some people at Homeland Security, almost none of the vessels that come into a U.S. port, and most ports in the world for that matter, are actually inspected by divers or ROVs. It's not really a thing, and so a very high percentage of them, at some ports, possibly double digits, 10-15%, do actually have narcotics and contraband actually like magnetically attached to the hull. Uh, Nobody checks them. No one can afford to. They've got dozens of these things going into a port every day. And although they may be listening for divers, it's not really it's not a big concern. I know security is probably a little off topic of this, but I think security also not just of that, but we saw with the Nord Stream 2 pipeline, like these assets are all very, very vulnerable. So I got to work on Nord Stream 2 and Nord Stream 1 just briefly. Um, there's 1,000 vessels every day that cross over any of these large pipelines anywhere in the world, and they can be fishing vessels, pleasure craft, and it's going to be a double-edged sword because something that big can take down enough explosive to destroy one of those. Maybe not pop a very big hole, but with the kind of gas pressures they have, you don't need much. And so it makes this extremely vulnerable. And so I could easily see a scenario where governments, agencies like the Coast Guard would want, not tens, not hundreds, but thousands of vehicles, either for patrol, for monitoring, or for actual countermeasures. As far as the science and offshore wind side, Offshore wind's pretty big, but I think honestly the exploration side and in particular like documenting corals, that's a really big business, especially on the small vehicles that we specialize in, because you can map a reef from space fairly well if it's 10 feet of crystal clear water. But then again, if it's 10 feet of crystal clear water, every master's student wants to go there and map it, with a scuba tank and a pair of flippers because it's fun. But mapping these reefs, like the Great Barrier Reef, doing the deeper reaches of that at 100, 150 feet, um, it's it's difficult but not impossible with a tether. But autonomously, it's very quick, as well as divers can't. You can see badly bleached coral, but someone I've worked with, he's did his PhD in coral bleaching, and the interesting thing about it, if you could see into the far red and near infrared, you can actually detect coral bleaching much faster. And it's very subtle changes in the proportion of various lights that are actually reflected, various wavelengths. And so to have an autonomous underwater vehicle that can cruise these reefs at 3 or 4 knots for 24 hours and just recognize we've got slight bleaching here, we've got slight growth here, bad growth here, good recovery there, and they're able to quantify that very quickly. I think that's going to be a pretty big market because it's also relatively low cost. I mean, yeah, there's some AI and some smarts in there. The actual computer boards aren't that expensive, the cameras aren't that expensive, and the vehicles don't have to be deep rated. We're not going to the bottom of the ocean. So I think that's going to be a pretty big one. So port security, environmental monitoring of reefs and shallow environments. I think those are going to be pretty big.
You've worked on treasure hunting, oil and gas, deep sea science, and filmmaking. Can you share a particularly challenging mission where you or your team had to improvise or problem solve in a tough situation?
Ooh, trying to think of one where we didn't have to. It's because it's so small and all the equipment's kind of unique, right? People have made something like this sonar. People may have made thousands of them, but they're used all over the world on every different kind of vehicle. Smaller vehicles, I think Video Ray are the biggest name in this space. They just passed 4,000 vehicles total in their 25 years not long ago. So that's not a lot. Uh, and so they don't come with the best instruction manuals. You just kind of have to, you have to think on your toes an awful lot. So one of the more interesting ones, but not famous necessarily, we were working in the Caspian Sea. It was 2014. It wasn't even an ROV, it was a geotechnical drill. And we were doing this thing called cone penetrometer testing, CPT. So it's very interesting. You have a couple of load cells and a very small probe, 10 square centimeters in surface area. You push this into the mud, and by measuring the force it takes to actually part the soil, and then the friction, the parasitic friction of the material, you're able to quantify pretty accurately whether it's silt or sand, and you're able to get a very accurate idea of the ultimate shear strength of the soil. So, if I lay a cable or a pipe across here, is it just going to sink in 100 feet or will it stay on the surface? And we had just a crazy problem of we had an electrical a communications issue where it was several different pieces of equipment all interacting. It ended up being ground loops inside the system, but it's one of these. It was very finicky. You couldn't really tell what was going on, and unless it was in the water, and everything was switched on and operating in a certain combination. So no one device was really at fault. It was the combination of 15 pieces of equipment in the water, had to be at depth to get a little more pressure on some of the cables, which changes the characteristic impedance of the cable when you squish the conductor, as your dielectric is squished down a little bit. And you've got seawater, which makes relatively fresh water there, which makes a like a ground shield. And it was that was an interesting one. I flew out there Christmas of 2014 with an oscilloscope and a whole bunch of probes. It was a lot of fun getting through customs in Azerbaijan and doing this testing. But that was probably one of the more exciting challenges I've had over the years.
So I'm going to ask two more questions and then we'll go right into the class-wide Q&A because I'm pretty sure we have some folks chomping at the bit. Um, so related to some advice for students that are looking to enter the ROV industry, what technical skills or experiences do you think are most valuable to pursue?
One of the things that was most valuable to me is troubleshooting, working on my own electronics, whether it was radio controlled aircraft back in the day, but a lot of it was from, I would say, mostly my late junior college. I got a couple of associate degrees in electronics technology, and they were really heavy on good troubleshooting skills. So your binary decision trees, trying to find a problem, or half pointing as they call it, and then being so having very good troubleshooting skills, and a lot of that went down to being very good with the equipment. So most students of any, honestly, a lot of hard sciences that aren't even related will have at some point touched a multimeter or an oscilloscope, but you just use it twice in physics class doing electricity and magnetism or something. You're looking at electrostatic fields or something like that. It's probably not. And you work the dials 2 or 3 times. It really helped me being in those classes, and then eventually getting my own equipment and working on projects at home. It really helped me. Just, you learn every in and out on the equipment. You learn as well the limitations of the equipment. But that, and I would say a lot of the engineers that I've hired and that I've seen hired alongside me or above me at other companies, they had almost no hands-on skills whatsoever. So they in most cases they're quite a bit smarter than I was. But you give them a couple of screwdrivers, a bottle of Loctite, and I have no idea what torque to put on this. What's this red stuff for? So I think being mechanically inclined, playing with Legos when you're a kid. I make my kids, I don't make them, but I encourage them to play with Legos, and they love that. And I think that probably builds more skills than anything else.
I can't say how much I agree with everything you just said. And the multimeter, that was something I got to much later in life. But if you work on cars, if you do anything with RC recreational stuff, in my case, getting into troubleshooting components on an RV,
Hmm.
you have to learn how to use these tools to read voltage and resistance, and it's not something you want to have to sit there and try to watch YouTube to get a tutorial on. The more practical hands-on experience you can get in a controlled and safe setting, the more prepared you're going to be for when things happen in the field. And yeah, they happen in the field when you can really least afford them to. But how you make do is really a testament to your character. One last question from me, and then I'll kick it over to the class. Peter, if you could work on any dream ROV project without a budget or technological constraints, what would it be and why?
That's a good one. You know, I got to work with Tom Detweiler once. I said that he worked on that Project Azorian, pulling a Russian sub out off the bottom of the Pacific Ocean. It was kind of a dream project because a small team of engineers with an unlimited budget from the CIA, just get it up as fast as you can and spare no expense. If I had to work on one project, I know exactly what it would be. I want to work with NASA on their ROV for Europa. There's not going to be anything cooler than that. Take Flying all the way to another planet using a nuclear reactor to melt through 2 miles of ice and then see if you can find life down there. with a what's it going to be, like a 2 hour delay between communications?
I can understand that. Yeah, that would be amazing. Taking that knowledge of what we've just really scratched the surface of here, and yeah, we're gonna go to a really something we can't even probably imagine at this point. So that would be exciting. Uh,
Hopefully not too long, but yeah, that's what I'd like to work on.
Class, I see William has a question, so I'm gonna kick it over to him. Feel free to unmute and go ahead.
Thank you, Peter. Appreciate the talk. I'm coming from the commercial UAS industry, and you mentioned that your industry is not as regulated as the FAA is. So I'm wondering, what is sort of the process for these various systems in terms of getting them, the equivalent on the FAA side would be like a type certification or some kind of airworthiness
Mhm.
certificate. What process and how thorough is that with ROV technology?
Okay, thank you for your question, William. That's good. It depends where you're at, so it depends what you're working on. Effectively, there's no regulations on you can't go into a marine sanctuary that doesn't allow, craft. But you can't. There's really no regulation if you want to go out off the coast of San Diego and put an ROV in the water. There's nothing about that unless you're in some kind of a restricted environment close to a platform. As you go out and you want to say you want to dive in a restricted marine sanctuary where you're not normally allowed to go, you'll have to contact the Coast Guard or the EPA or whoever it is, and they will generally have their own little set of requirements. Like, for instance, some things in the Arctic, you have to basically tell them either there's no hydraulic oil in this, or there's no fluids in this that are not biodegradable, or if they are, here's what they are, here's how much, and here's what we've done to mitigate the possibility of leaks. Um, if you're working in around, for instance, a lot of platforms, there is a certification body called DNV, and they certify kind of everything. They're a little bit like Underwriters Laboratories or something. They are completely private, but the government does also adhere to a lot of their regulations for offshore safety of personnel. And so they have various requirements. And so these companies will often say you need to meet DNV cert X, Y, and Z. Usually it's related to things like high voltage isolation and safety, or release of pressure, or stored energy. And so they'll have some of those, but I I like to say this industry is kind of where aerial drones were about 10, 20 years ago. Uh, we were flying, I was flying drones, like remotely operated FPV things on a little black and white TV monitor in the like 2000 or something. And some of the guys there had been doing that since the late 80s. But there's like three people. No one cares. As long as you're not flying over an airport, no one actually paid any mind. So does that answer your question, William?
Absolutely. Thank you so much.
All right, thank you.
So next up,
Who's
I think
next
it
here?
was Sam or Joe. I'm sorry, Joe, and then
Right. Hi, Mr. Schubert. Thank you for taking the time to speak with us today.
My
Uh,
pleasure.
I had a question for you regarding the cutting the tether, so to speak, making drones more autonomous.
Hmm.
Um, and it relates to the energy budget, um, which you have to work with there. If you're integrating more AI, which is going to get more robust over time, that's going to increase the energy need. And I was
Hmm.
wondering if there's any kind of strategy going on within the ROV industry in terms of balancing that for the operations.
Very good question. Yes, obviously we don't have the power budgets. We can't put a full GPT system down here. We can't have Grok doodling around drawing cartoons of the environment for us while we're down there. Um, but of course, basic navigation, just trying to do just some basic maths to actually get you from one location to another. You can do that on an 8-bit processor. It's this SLAM work and then object detection and recognition, we are a little bit limited. There's some really exciting things in that field right now. Not so much with the AI, but both with batteries. And I just did a talk on this last year at Offshore Technology Conference, but basically trying to squeeze a little more power out of things. So there's a regulator company or a IC manufacturer, a package manufacturer called Vicor Power, based out of Massachusetts. They have these I had one on my desk here somewhere. Got a 3D printed model of one. Love 3D printers. So this is a 3D printed model of it's basically it's a package where they take a small ceramic carrier and with really good heat dissipation and a little copper backplane, and they will place very, very tiny surface mount components and basically bond everything together. So that this little circuit board with that part on it and a couple of little filters is capable of about 2,000 watts. It's a 2,000 watt power supply that is 98% efficient. And what the presentation was about is we're basically borrowing this from the EV industry. So Chevy, Tesla, everyone, there's been a huge push in these. And so they're taking, for instance, a lot of cars now are migrating from a 12 volt accessory bus to a 48 volt accessory bus. And then you'll have either like 380 or maybe 800 volts DC for your main power. And so people need to convert back and forth between that. And so some of these new converters are just light years ahead of what people had. So as far as getting power down the tether, or when you cut the tether, being able to convert between those. And then another one, here I've got one. This is a electric double layer supercapacitor. So this one is about 300 farads. It's not nearly as dense as they can get now, but 300 farads at 2.7 volts. This is a couple orders of magnitude better than previous capacitors. Now, it's not as energy dense as a battery, but one of the things we run into with ROVs is power demand varies quite a bit. So while you may have, let's say, on one of the systems we've got similar to what I have back here, just a little larger, you'll have about 1,000 watts peak power usage. But if you graph your power usage per dive time over, let's say, like an hour or something, you're usually only at 20% of that. And these large peaks, these large spikes in demand are often for less than 5 seconds. So one of our projects, it's not a product yet, just a prototype, but we're doing supercapacitors that give us basically about 30 seconds of a turbo mode. And so we're able to shrink down. It also enables you to use smaller batteries and keep them more efficient. So we're able to shrink down the power source a little bit and then go to supercaps. There are people using this on very large ones where you're using a hydrogen fuel cell. Fuel cells absolutely hate changing demand. They do very, very good on like a boat or something, or on a spacecraft where you just need to make 2 kilowatts and you can start it up nice and slow and leave it there, and then you can slowly shut it down. They do not do well with rapidly changing demand. So that short answer is modern power converters, denser batteries, trying to borrow them from cars, some of the larger design cells now, 22650s, I think they are, and then supercapacitors to try to even this out and augment it. And the last thing I'll say is also lighting. I just had one of those here too, but it was all incandescent bulbs or high intensity discharge or HID lights just a few years ago, and now the subsea industry, they've really all moved to LEDs now, and even effectively strobe photography, where you're strobing the LEDs about 20 times per second or so at very high intensity, and you're alternating different color temperatures to try to build these interesting composite images.
Thank you.
You're welcome.
I believe Laura is up next, and then Omena.
Hi, Peter. Thank you for the presentation. All right. So with your background in oil and gas and deep water exploration, did you receive feedback from any of that time, or did you personally identify issues that you were able to address or that influenced the design of your ROVs? Because I feel like affordability is almost a natural progression of just technology in general. So I was curious if there was anything specific that you were able to make better with your designs.
Well, thank you, Lauren. The thing that actually got my wife and I started is most of, and it varies widely by company, right? Some ROVs, what they'll do, you're going down and you need to lift an enormous, you need to salvage a cannon from a ship and it weighs 1,200 pounds. So you need a big ROV. You're not gonna do that with anything smaller than, a car. But an awful lot of the work, especially in oil and gas and wind farms, is actually just survey work. You literally just need an eyeball down there. So the smallest eyeball that can see good enough for the job and the propulsion to move that around will be enough in many cases. Now, the problem you have with the tethered system is that cable. And so our tether, I'm just looking around for a sample of it. Our tether is going to be on a small system, like most of ours, that's going to be about 9-10 millimeters, 3/8 to a half inch in diameter. And that tether, it's going to be the drag of that tether through the water that dictates how much horsepower you need down there. So the autonomy angle does help you, but you still have distance. So if we make a very, very small couple of propellers and a little tiny camera and a little battery, if it still has to go down, half a mile and then it has to swim 5 miles along, it's just not going to be able to get the range out of that. And so you're going to need a tether, but as soon as you put even a 1/4 inch diameter pencil tether on that, if you have to have half a meter of pencil sized tether out, you need an ROV this big with 3 or 4 or 5 kilowatts to pull that through the water. And so trying to balance that. But when I was offshore, even as late as like 2018, when we started the company, most of this was still done just for convenience with systems they already had for other tasks that were 4 or 5, sometimes 6 tons. And you just didn't need that. You needed something like what I have behind me here would work good up to like 200 meters, 300 meters of water for most of that. The larger systems we have will work good up to 1,000. And so my wife Christine and I, we were looking at that and looking at people's budgets and saying, you're spending $60,000 a day to go down and just look at a couple of valve positions. Well, and so we started trying to optimize. A lot of it comes down to basically unit thrust per cross-sectional area of the vehicle, because very often you can't just fly straight into it. You actually need to be able to maneuver around like a helicopter. So you've got to be able to take winds in all directions. You got to be able to fly sideways or backwards. And what we ended up with is that's actually a blue ROV that's in the background, by the way. I apologize. Our techs are tearing apart the other one right now that we have here. But what we ended up with was a vehicle about twice that size, running about 1.5 kilowatts power. And we had kind of worked up that was the ideal size for most of the shallower support work, up to maybe 500 meters depth, where you could use that on a small boat. But the cost savings just really, really add up. If you can take a boat with 5 people on it, 6 people on it, maybe 10 if you need a lot of surveyors and support. But it only has to be a 40-foot, 60-foot boat, and you can run out in a fjord in Norway or something and do that exact same survey with 6 people on a 40-foot boat at less than $5,000 a day. So that's kind of that was sort of the problem that we were really looking at. And a lot of that was also related to, and this is kind of what we use in our bio here, is we're trying to bring the lessons from big RVs to small vehicles, because a lot of these small vehicles, they still have 2 lateral propellers and 1 on the top for vertical thrust. They have no real XYZ stability. They can go forward, they can rotate, they can kind of go up and down. But the minute you have the heave of the boat pulling the tether or something, they start rocking. You don't get a clear sonar picture. Is you think you're looking at this nice fan of a sonar image, but really it's going up and down like this. Because the tether's doing that. And if you look at your roll pitch indicator, your artificial horizon's going up and down plus or minus 20 degrees. So trying to take the lessons of a big ROV, because a lot of research money did go into that, and apply it to the smaller ones. So I think that's what we're, and I hope that answers your question good. That's really what we started out trying to do here at Poseidon.
No, thank you. I have a follow-up question, but since there are so many other hands up, I'll refrain. So thank you.
You're welcome.
And folks, if you want to reach out to Peter, please email me. Peter, I don't know, do you want me to share your contact info?
Yes, please.
Okay.
Pass it far and wide. I'm always happy to answer questions. And, sometimes I get some students that have a project and they need some housings or some props, and I can either sell them to them or I can point them to people who have what they need. So I'm always happy to help.
Outstanding. And next up, I think, is Omena.
Hey, Peter, can you hear me?
Yeah, loud and clear. Go ahead.
Sweet. Thanks for taking the time to talk with us this evening. My question is kind of piggyback off of, I think it was Will or another classmate talking about the current requirements and regulations for certifications, and you stated it's more dependent on industry right now. So do you foresee in maybe 20 or 30 years, this, like, the regulation certifications for US waters and coastline or international, being more so akin to national airspace system for commercial and military AUVs still being dependent on industry, or kind of like with UAVs, more like weight or like a mothership required, or AUV versus ROV or other characteristics?
Okay, thank you for the question. I think it'll be a lot quicker than 20 or 30 years. Now, kind of like drones, and I mean, I kind of fault the FAA a little bit. So I was into them, ages ago, and they've gotten pretty good. What was it, about circa 2018 or so? But there was a period there of like 15 years where there were people who said, "Hey, can I go out and inspect your hydroelectric dam, or can I go fly your power lines and look at them or something?" And people had like, "Well, what do we really do with this? He's not banned from doing it, but we have a flight, a temporary flight restriction over here. There's no like way to license you." I think there's this added element of danger with air travel, which is you have passenger jets and you have, recreational and commercial helicopters flying along, and there's not really a good way to land when you crash. You don't. If I fly across the runway, we're only like 30 minutes drive from Sky Harbor here in Phoenix. If I fly a drone across the runway and that nice big old Ferris motor goes in and hits a turbine blade, it's probably not going to part it, but that engine it's going to be shot, right? If that plane were to crash, you can lose a few hundred people in the actual aircraft itself. You can lose a few hundred more people on the ground. You can lose tremendous confidence in the industry. With the ROVs going 2 knots, and maybe bigger ones with enormous props that could, take a finger or something. But with these small ones, I can't do anything very threatening with it until you actually go to actual warfare and you start putting explosive charges on there. I can't really do anything threatening with it. I could try to fly at the sub. So we went down and actually flew at just outside the sub pens at Point Loma base in San Diego, but I was invited there, so it wasn't a big deal. But you can do that. There's already good countermeasures and things if you get too close. But I do see them having a bit more regulations. The surface vessels, once you forget how far offshore, you've got to file your float plan, basically similar to a flight plan. You can get a few miles outside. I've got I've got a story we don't really have time for, but I was out on a small little 16-foot boat doing some RV ops off of Newport Beach in California, and I went just a little too far out because I wanted to get some deep water. So my brother and I figured we'll just run out another quarter mile and drop it. The Coast Guard pulled up on us in about two minutes. Let's see your IDs. You guys have your papers here? What are you doing out here? And so it's monitored there, but I think they're going to start requiring it'll probably be fairly simple, but I think they're going to start requiring maybe not necessarily registration for recreational use, because again, you've got to have the boat to get out there. But I think they're just going to require, like, we want a little transponder, little acoustic transponder on it, or if you're going to go out and do any subsea ops in an area, we want to know about it. In some areas, you're already required to do that in Europe. But yeah, I think there's going to be a lot more regulation, and you saw that with Nord Stream, with the Nord Stream pipeline, and it's going to happen again. Talked to a number of people at different agencies who basically consult for the U.S. military on this, and the next sort of hybrid warfare. I mean, you've seen what they've been doing with drones in the conflict in Ukraine. The next time they have some kind of a hybrid warfare in, say, in Western Europe or Norway, or if you have something in the Strait of Taiwan, those will be used almost immediately. So people are just going to be taking out piers and water intakes and sewage outfalls and subsea cables. Pretty much anytime you see a subsea cable stop working in Europe or Southeast Asia, it didn't stop working. Somebody went down there with an ROV and cut it. So yes, I think there will be more regulation. I hope they're able to get it out a little quicker and smoother than the FAA did with drones, but I think there will be soon. Does that answer your question?
Yes, sir. Thank you, Peter. I appreciate it.
So
My
next
pleasure.
up is Sam, and then I want to just real quickly go through some questions that we have in the text chat, and then we'll jump over to our three remaining folks, and I think we'll close out after that if that works.
Cool. Can you hear me, Peter?
Yeah, loud and clear.
Cool. Yeah, so I heard you mention some stuff about photogrammetry, which is what I do at Boeing. I work in that, we call it metrology, but I work for commercial, and we do some of the defense derivatives of commercial aircraft. But I was just thinking about what you said and thinking through the complications of doing that at depth and with different lighting conditions, because photogrammetry inherently has no scale. And so I was just wondering, how is there some kind of scale bar artifact that you guys check, like when you're above the surface first, and then how do you adjust for that difference because if you set to an artifact that's at surface pressure in the air, it's very different under the water. So there would need to be a secondary artifact in that specific environment, because usually the cameras are calibrated to laboratory conditions, right? 68 degrees.
Yeah, that's right.
Constant humidity. So I was just wondering if you were familiar with like what is going on there, and then also what software you guys use to actually process the images for the point clouds.
Okay, great questions. I'm not the SLAM expert. If you like, I can put you in touch with somebody in the UK who is. He's got his own little third-party company. He makes his own cameras. He's a PhD. He did sonar for a while, just developed his own acoustic elements, and then he ended up doing photogrammetry. It's much more convenient in aerial drones than it is subsea. Much of the world we work in, like for instance ports, I was down in Florida recently, and you can't see maybe 6 feet in most of the ports there. You get actually down to the Keys, and it's nice, but in the ports there, that's just runoff from all the farms, and it's just green or brown or black. You can't see much. So to do actual photogrammetry, you might need to be within 5 feet of your target. Completely different than being able to fly over Central Park with a drone and just map most of the trees there in an hour. You'd be, with an ROV, it might take you hours to map a ship's hull or something. We do calibrate. It depends what camera. what a lot of the people will do, the distances aren't thrown off as much though, and that's because you're not looking thousands of feet, you're looking tens of feet.
Yeah, that makes sense that the scale, the compounding error from scale error will be super small because the actual size of what you're looking at is so small.
Yeah,
So I
and
guess
now
that's something I'm
one of the problems, so usually when people use photogrammetry, it's not of a marine biologic structure. It's not of, you're not going down. I know people who have mapped seafloor smokers and things like that. In that case, what they'll do is the ROV will just place a great big old scale bar down there. And it's
yeah,
just
yeah, yeah.
your little
That's what I was
checkered
thinking is
pattern, and
it could
it's
almost just
one
have
meter
its
long.
own scale bar that it would just bring with it and then just pull it in
Yeah.
front of the camera or spin back, take a picture, and then keep mapping, keep taking
But
images.
for a lot of what they're doing, mapping ship hulls for a defense, for instance, is a big one. The other one is in the hydroelectric community. These dams were put in, 50 years ago, 70 years ago, and they'll have these big gates installed or these intake pipes or valves. And so usually there's something there that they are absolutely certain how big it is within, 0.5% or less. So they know that this pipe is exactly 1 meter across, plus or minus, 5 millimeters, 10, maybe 10 millimeters or something.
Yeah, so using known lengths in the images to define the scale. Yeah, okay.
Exactly. And very often they're not. And to be honest, usually when we're doing photogrammetry, they have photogrammetry and then you have the actual slam mapping, right? And slam is what's typically used where you have a stereo camera. Now those
Yeah.
suffer from the same problem that you do want to calibrate it. So you'll
Yeah.
typically have a calibration board. The refractive index of water varies a little bit with pressure and temperature, but not
That's what
actually
we
that
have to
much.
compensate. I was thinking that water would be more stable than air, right? Because humidity in air is one of the big problems we run into, especially if you're inside a hangar, outside a hangar. If you're comparing results to someone in Charleston versus someone in Seattle, you have very different humidity and temperature. And so, you have to be very cautious that you don't just that you apply scale accurately. And we usually work to 33 thousandths or some the final tolerance is 30 thousandths, but we work to about 3 is our expectation of accuracy. But usually we get to like one
Oh,
and a
that's
half.
fancy.
Yeah.
That's really good. Usually what we're doing here is much simpler, and I don't want to go too long-winded. I know we got to wrap it up, but short answer, you can take a calibration board down if you
Yeah.
want to be really accurate. And it's not as big of a thing in shallow water, but in deep water where it's often used. I know the guy who went down to scan the entire Titanic for that project. They take a calibration board with them because
Okay.
you're going to depth, and so they want to do it under those lighting conditions. But yes, the lighting is not ideal, and you got to be very cautious with it. But I hope that answers your question. I'm happy to talk more about it at another time too.
So switching over to our text chat here, we've got Jerry asked, how long did it take Poseidon Robotics to design the Maui Gen 2 and Lanai? Also, how long does it take to manufacture them? And have you completed ROV expeditions similar to Sea Innovation's Titanic wreck site expeditions?
Not yet, not yet. So in order, the Lanai vehicle, I had made a lot of the accessories for the Blue Robotics Blue ROV to start with. So we built surface power supplies and different grabber jaws and junction boxes and things. And then eventually we decided we'd built our Maui Gen 1, which took about 4 months start to finish to design that one and to build about another 4 months to build the prototype, 8 in total. Was right at the start of COVID. And we figured if we can't go to trade shows, this probably isn't going to work very well. So we decided to go scale down to a smaller vehicle where people wouldn't mind us not flying to Norway to sell it because it didn't have profit in it. And so that one I designed in, I think, 7 days, start to finish. I think it was just a week to make the original Lanai series. So that was that was the main circuit boards and power supplies and the housings and the frame and everything. So, but I had a good background. We were just iterating. The Maui Gen 2 I designed in about 2 months. And then the lanai we can make in basically maybe like 4 days or so, but we're a small company. We got 5 people here. So we can make it in about 4 or 5 days if we want. We could do it quicker if we were batching them. And then the Maui, first one we built took probably about 20 days start to finish. But again, it's not an assembly line. It's a couple of people wrenching on it. So, and we can't have every single part prefabricated. So we'll solder the harnesses ourselves and twist everything up. It's a decent amount of work, but thank you for asking about the vehicles. No, I would love to go do a big project, like go try to find another ship like the Endurance or something, or go map Titanic. But in those projects, it's the vessel that costs all of the money, and or the getting permission and getting approvals, and or paying the salvage tax basically to go out there and do it. We've not done anything that cool. I did get to work on that project for the History Channel. That was a lot of fun. That was Bermuda Triangle into Cursed Waters, but we actually departed for that out of we actually departed for that out of the port there at Daytona, which was kind of exciting. So we've done a few trips out of there looking for the wreck. But I would love to go. A friend of mine and I, we have a project. We want to make a very small AUV, small as we humanly can, to kind of prove it. And we want to go out to Challenger Deep and just drop it down. Go all the way to the bottom, do a little survey at 11,000 meters, and pop all the way back up and hopefully find it.
Very good. Christian asks, what about the new AI DeepSeek that can run on a Raspberry Pi that just came out? Is that something you envision as something workable into future designs that you have coming up, or?
Possibly. I'm honestly not familiar with that one. I know people have tried different types, and AI is a term that gets thrown around very loosely. Some people, to some people, it means it is a sentient artificial intelligence. It can pass the Turing test. It might try to take over the world. And to some people, it's basic. I've seen people apply it to a very simple neural net.
This is a GPT. It's there in like direct competition to large learning or language models and things of that nature. The big claim that they have is the cost is extremely reduced in comparison to like ChatGPT and etc. The other aspect is, and this is where I think it's really novel for what we're talking about here. They claim their power requirements are substantially less. So that means at scale, this potentially could have game-changing properties. If the cost to use it as a subscription is less, and if the environmental impact is notably reduced, that's less that if you're running it, say on your own hardware, and it can run on a Raspberry Pi. That's the other crazy thing about this. Doesn't need a big NVIDIA chipset and an array, like a GPU. So it has some pretty interesting properties, but I don't know how much is smoke and mirrors at this point because it's so new. It's just out there. I think we need to spend a little more time with it to figure out what's.
Yeah, I'll show you the battery we use. So for the small vehicles, I mean, most of ours are powered through the tether, so you have
Is
an
that
inverter
NEMO
on your boat.
or is it lithium?
This is just a Blue Robotics with a XT90 connector on the battery, and this is
What's your chemistry?
So these are standard lithium ion. These are basically laptop cells. Not the best discharge rate. I would not recommend pulling too much. I've fried these, but these are 266 watt hours, and you'll never get all of that out, right? So There's a couple things. I mean, large language models might not be for everything. I have a background in programming. I did a lot of embedded firmware, and we were using neural nets, ages ago, but they're usually very limited. Something where people use them a lot for simple decision making. You will actually use an FPGA and you just use lookup tables and you apply a couple of weights to it and get through it. But you can do a lot of computations very efficiently, very low power. And so you don't necessarily need to be able to interface like GPT and any of the OpenAI video creation, Grok, any of those. It's really interesting for a human to be able to type, what is the coolest looking cake I could make at under 100 pounds and why? And why should I eat it? That's a very it's a very artsy question, whereas a lot of robotics navigation is I can do
Discrete.
a very simple lookup table or some very simple algorithms or maybe some very reduced heuristics, but I can do it on an 8-bit processor at 2 megahertz because do I detect something in front of me at a short distance? No. If I do, 80% chance I go right, 20% chance I go left, and I try to find my way back right. So there are ways around that. I don't know that it has to be a computer model that could do everything, but deep learning for image recognition can be a little bit hard. But my understanding is it's not, and people use very limited processors like Raspberry Pi 3s and 4s to do, for instance, voice recognition, where it's only one person's voice. You only have to recognize like 1,000 words, so it doesn't have to be able to answer every question on Earth. It just has to know which of these 1,000 words did this person likely say in between this dead space. And so I think a lot of these missions, these AUVs will be simply like you're flying along a subsea cable and you're saying, is the cable visible? Is the cable buried? If it's visible, is that a barnacle or a bomb or something else? Take a photo, continue flying, and just object detection. Am I going to crash? Yes. Fly to an altitude deemed safe, get back down as quickly as it's clear, and continue on. So you can do it with an 8-bit processor, but it takes a lot more thought. Whereas I think being able to actually do some simple training on it would be very advantageous. But people are working on it. So yes, I think it'll be relatively low power processors for the navigation and flight. And then the image recognition probably mostly be done after the fact, which people are already doing.
So Leo asks, and this deals with more just configuration of designs. Do you use a mothership type setup when a bigger remotely operated or autonomous UUV underwater vehicle carry and release smaller ones, such as to provide a communications relay from surface down through a tether to the ROV, and to potentially recharge them on as needed basis?
Yes, but not very commonly. So there's only been a couple instances where you actually have an ROV or a UUV deploying another one. One was for the one was for Ghost of the Abyss. The other was for Titanic to actually film the scenes inside the ship. They made a sacrificial ROV and just flew it in and left it. Actually, I think one they left it, the other one they managed to get it back out and they left the tether. So that's usually only used in unique applications like that. Sometimes they're used, I worked in geotechnical, they're used on subsea drill rigs where it's a small rig and you're just taking core samples. We did a little job on the East Pacific Rise, just trying to take some basalt cores and see what it was made of. But on some of those, you will have a small fly-out vehicle that's for the cable's stuck or something like that, or there's some problem where we just can't see it with our cameras. Can you fly around and look at it? That's not too common, but there are a few instances where people, and there's a lot of chatter about this in Florida, funnily enough, in the coastal security region, where what they're worried about is somebody dropped off a package of drugs on a boat sailing in. They may be going out to retrieve it. We'd like to send an autonomous surface vehicle out, or a remote service vehicle out, drop a small ROV just to look at it and say, "Yep, that's a package of drugs. Send a cutter out here with a dive team to recover it." There's a lot of interest in that right now, and then some people have been trying to do them for reef monitoring as well, where this surface vehicle will stay in place and it's solar powered, and so you don't have to anchor, but it can drop the vehicle down, reconnoiter something, and you have your link, and then you have your Starlink on top of that, or your cellular modem. So
Excellent. That comes to bear in a problem that some of our classmates are looking at this week in one of our classes, where they're looking at a very large surface area of water where a wreck went down in a 90 square mile area that contains some radiological material. So they need to try to find it quickly using a variety of methods. All right, we've got three more, and I apologize about the order. I wasn't paying as much attention to whose hand went up when. So I'm going to start with Bob, and then we'll go to Alexander, and then Mark.
Okay. Can you see me or hear me?
Yep.
yeah,
Cool.
Loud and clear.
I'll just ask a quick one, Peter. So I've been looking at I was thinking of getting an entry level ROV, something like the one you have there, and I was just curious, how much does that one run? And do you have any besides maybe? I mean, you might have a Poseidon model that you would recommend, or maybe another COTS model for an entry level model UAV that somebody would go and get that would be useful. You know what I mean? In the long run.
Okay, good question. I'll make it short. So, I do like the blue ROV, especially if you're trying to get into it on a budget, because you can't really get much cheaper. Some people have built cheaper out of, bilge pumps or something, but this, as it sits right here, probably run you about $8,500 by the time you get the ROV, a couple of batteries, you get the modem, and I always like having this because it's lighter weight to show off, and you get a 150-meter reel on it. I will usually install a connector. That's something we could do for you, but you can just as easily do it yourself. But you could get in a little below that, but basically you're looking somewhere around $7,000 to $10,000, depending on the configuration that you want. And then ours start at basically 39,000 and go up from there. Depends kind of what you want to do. To be honest, most of these ROV manufacturers, us included, we have standard pricing, but people want something custom, so there's usually something else in there. We will give an educational discount though, but always feel free to call me up. I'm happy to help you out with spare parts or help you select something. You can, if you want a really low cost one, the Chasing brand of vehicles. They're Chinese made. You have to link your phone to them, just like some of the smaller drones. But I think they have one on Amazon that's $1,500. So not a bad way to get started. If you email me, I'll send you a link to them.
Cool. Yeah. Thank you. That's about the price point that I thought that one was going to run, like you said, depending on the configuration. So I think maybe I'm more in the 3,000, for entry level. You know what I mean? But
okay.
Thank you.
There's some good ones on Amazon or from some other manufacturers. I know some people. Just send me an email. I'll happily give you a list.
Awesome. Thank you very much.
You're welcome. Who's up next?
Alex?
Hello. I wanted to say that it was really neat when you talked about how the possibility of using these ROVs for law enforcement to find people that may have fallen through the ice. I grew up in northern Michigan, and it still happens to this day. A handful of people disappear into Lake Superior every year. But my question is we've seen with the California fires, UAVs and the firefighting aircraft crashing into the small UAVs that aren't supposed to be there. But when it comes to underwater capabilities, is that you have people with their own subs or even military subs. How much of a threat is an ROV to one of those subs?
Good question. So in rivers and lakes, not much, because again, the speeds are slow. Vehicles are often used for diver support, and one of the few places that could be a problem is a very large ROV with a diver, and you have unprotected thrusters. So on the large systems, you're doing diver support. If you didn't check that anyone was going to be in there, because for divers, they will put a big mesh over the props because they're about 40 horsepower. And if you get your hand close to it, it'll go right through and come out as sushi on the other side. That's only the big systems. A diver can hear that from about a half a mile away. Maybe not that long, but they're quite loud, they're quite noisy, and again, they're slow. They don't swim any faster than a diver. On these small ones, there is a little danger of a diver becoming entangled. We sold one to a small system. It was actually a blue ROV, one of our first. We put power on. We sold it to Sacramento County Sheriff's Department. They had lost a couple of divers in the river there where they're crawling around. And if you're not familiar with it, in poor visibility, the recovery divers will weight themselves like 30 pounds heavy, and you crawl along the mud and you can't see anything. You're just hoping to grab an arm. Kind of morbid, but that's the easiest way to do it. Sonars make that kind of a thing of the past now. And they had a few divers get hung up. They were in a high flowing river and they got hung up in a tree, ripped the regulator out of their mouth. They were never able to recover it. So ROVs can honestly have a pretty good life-saving or just risk reduction potential, because you don't have to put somebody in the water. One customer we sold the vehicle to in Utah, they had recovered a couple bodies, guys capsized in a small fishing boat, and they were able to pull them up just with the grabber on a small vehicle. They were able to pull them up from 150 feet. The divers never even get wet anymore. They just fly down with an imaging sonar. They can spot them quick. They pull them up, but there's not the same risk. I mean, it's a really good comparison. The risk is just slower because of the kinetic energy, right? It's 1/2 mv squared, and there's just not much velocity. The velocity is so low. Where people get really angry, but nobody gets hurt, is where you're working around like azimuth thruster pods on a large ship. It's just a huge propeller, especially where they have a hub, not the hubless ones. Not with a tether this big, it wouldn't even notice it, but these large tethers, they are Kevlar, and Kevlar does not cut nicely. It just fouls and it wraps around the prop and gums it up. And so what happens is you have a big work class vehicle getting too close, and all of a sudden it just sucks it right through, dents it up, damages the propellers, the cable gets wrapped around the hub, it cuts it eventually, but you have to go into port and you have to lose, a few $1 million in revenue while you're in dry dock getting this fixed. So no, I don't think the same risk to human life is there. At least not for shallow water recoveries. I'm not aware of anyone who's had a collision where a large rubber coated stainless steel object cuts a cable, but I'm sure it's probably happened somewhere where an actual Navy nuclear submarine has run into something, but they can hear these a mile away. So I don't think that's going to be much of an issue. I think overall they reduce risk pretty good. And most of these cases, you're going to be well aware that the ROV is there, and they do have procedures on board vessels. Once the divers go into the water, the ROV is not allowed in unless they're doing dive support. They have a meeting beforehand. And you're kind of limited in the range too. So
thank you.
You're welcome. Thanks for your question.
Mark?
Hey, Peter, thanks for the presentation. I used to do a little
Pleasure.
scuba diving, so I find this topic really interesting. I think there was mentioned that there were some you had some experience with treasure hunting, and there was some talk about, cables sometimes getting buried below the silt. My question is, could you talk about any capabilities for detecting objects that's sub sea floor? Like for instance, like using ground penetrating radar or metal detector or something like that for things that got below the silt. So the treasure hunting is really fascinating to me because I used to follow some the treasure hunting that
Right.
occurred in Florida, where they Mel Fisher and all those guys.
Yeah, thanks for your question. So I've been dealing a lot with this topic, more actually for oil and gas, and actually there's a big electrical cable lay project that I've been involved in, just providing equipment to, and this comes up an awful lot. So it's fairly well understood. Radar doesn't work very well. As soon as you get below the water rate, water is a nice polar molecule, and it just likes to absorb heat. It likes to absorb electromagnetic radiation and just warm the water. But what is commonly used, some people will use gravitometers, but it's almost all, if for treasure hunting, it's usually, or UXO identification or location, it's usually going to be towed magnetometers. So there's a very sensitive magnetometer. You put it on a synthetic cable that's running power and power over a coax, and this thing will have a set of fins. You tow it just like a deep tow, like trolling for deep sea fish or something. You'll tow this well behind the boat, and you'll set the altitude right, and then you'll just go back and forth across the ocean bottom for a while looking for something. It's not good figuring out anything that's down there. It just says you have a large anomaly that could mean a big block of steel down there, but it doesn't tell you if it's Titanic or a cable or a sunken submarine. You don't really know. That is going to be your widest detection range by 2 orders of magnitude. Below that, we have basically multi-beam echo sounding sonar. So what you're doing, you have a sonar facing down, usually from the hull of a ship or from an ROV when you're in very deep water because you can't resolve much. And you drive a high energy pulse down. It reverberates off the seabed, and you're looking for something on the seabed. You can look below it though, and if anybody's really into wave theory, this is really cool. But in the old days, you would have either an air cannon, you would literally throw some dynamite over for geophysical, or for modern it's called sub-bottom profiling. There's a few companies like Edge Tech that make sonars for this. What they'll do is they either have a very low frequency acoustic driver. It's very high energy. It's just a huge piece of piezoelectric crystal, and you put, or usually a giant array of them, and you put a tremendous amount of, 25,000 volts at a couple of kilojoules behind this. But mostly what they do now, they will create a beat frequency from a whole bunch of very high frequency, high efficiency piezo elements, and you'll create a frequency in the kilohertz or tens of kilohertz, maybe 2 kilohertz to 30 kilohertz, and that acoustic wave will penetrate silt. It goes through water for kilometers. It'll go through silt quite a ways or soft sand, and then it'll reverberate very nicely off bedrock or off buried cables. Of course, as the wavelength gets longer, it's going to be harder and harder to detect smaller objects, but it's pretty good at finding something like a cannon on a very soft bottom. They're commonly used in the Great Lakes, and they're used to look for a cable or an oil pipeline that's sunk into some soft mud, or it's like all the pipelines that were laid in the Delta outside of Louisiana, out the Mississippi Delta. You lay the pipeline from a little shallow platform in 300 feet of water, you lay it up to the beach, and 50 years later, there's nothing visible on the surface, right? It's all buried under there. So sub-bottom profilers, when we get really close and you're looking for a metallic object, you can use magnetometers. Sorry, not a magnetometer, but a forced induction magnetometer, or basically a metal detector. So these are often just called pipe trackers, and they're meant to locate a cable or a cannon or a bit of unexploded ordnance that is 1 meter to 3 meters below the surface. They're really good at that. if you got a 200-pound bomb somewhere in the Baltic with a little bit of silt over it, they're really good at finding those. So that's basically, most treasure hunters will have a towed magnetometer. They'll fly an enormous pattern because you're looking for one object in 1,000 square miles and you're hoping to get lucky. They get a few targets of interest. They have no idea what they are. Then they send the RV down to look for telltale signs of a wreck.
Would it be possible to attach either the magnetometer or the metal detector to the ROV or a UUV?
Yes,
better.
but in general, you're looking for this much signal and now this much noise floor. So it gets fairly difficult to do. It is possible. I can put you in touch with a few people that are doing a bit of this. We're going to try and do a little bit more. We've got a crafty plan to basically integrate it with the software, and we just want to drive the vehicle for 2 seconds, shut it off for a half second, make the thing electrically silent, listen, and then turn it back on and continue flying. But it is difficult. But I think, yeah, towed magnetometer is basically what you're looking for. Although in treasure hunting, there's very often enough scarring on the bottom to be able to see it. It's not usually completely featureless. There is going to be some mounding, or there'll be a reef that's grown up over what used to be the wood of a ship. And then you may see it in you'll see a reef in a nice little outline, and you break through the coral and you'll see the ballast stones in there. And then maybe you find a cannon with metal detector. Does that answer your question?
Yeah, thanks a lot.
I can send you some model numbers and some info on basically what you're looking for, but unfortunately, they're mostly very expensive. Everything except the camera to look at it.
Thank you.
You're
Tremendous. Well, I want to just say thank you to everybody for joining us tonight, as well as just a big thank you to Peter for sharing his thoughts and expertise regarding this technology. This has really been just a tremendously informative session, and I hope has helped you to gain a better understanding of the challenges and opportunities associated with the development and use of maritime underwater uncrewed systems. Just to the classes, remember, for full credit, you need to add a brief discussion entry, just a single text or video post by Sunday. You don't need to add in the usual requisite 2 peer responses. For UNSY 501, remember to describe how what you've learned here supports UNSY technology or capability. And for 502, describe any examples of identifiable IP or even potential protections that might be usable within this realm to safeguard innovation. And on that, if there's anything you'd like me to share with Peter regarding your thoughts on that front, I'm happy to, or you're more encouraged to reach out directly to him. I did put his contact info into the text chat. So
thank you for doing that.
Oh, no worries. Thank you for coming in. I really do appreciate it. One of the biggest challenges we have is getting folks in on the maritime front to talk about this. And, we like to paint a very cohesive picture of this technology, and we understand there is significant overlap between maritime, aviation, and space, that it's good to know the unique elements as well as the commonality. So as we are looking at solutions to problems that come up, if we have that depth of understanding or exposure to those other operational environments, it really helps. So,
all right. Well, I would love to get into space one of these days. There's not a lot of water there, but there's a couple of moons that would be interesting.
Excellent. I'm going to stop.